Good afternoon, everybody. So, outside little bit cold, inside quite hot, right? And it is said that now monsoon has started. So now you are saying, when will monsoon come? Will monsoon come? When monsoon comes, then you will be tired. Oh, monsoon, when will it go? Every time raining, when raining and raining. Clothes also wet every time. Shoes wet, muddy roads. Yes or no? Tension time. We are discussing about the chapter Force and Motion. Students are presenting, and whose duty is to present today? Soni's Guru. Only he is presenting. And which is Super Guru? Simresh. Sonis is going to explain about, I think, measuring weight of the body. Relation between. Okay, okay. So numerical problems already solved. You must solve it time and again. You must understand the things and do it. Eh? What is the page number? Acceleration due to gravity discussed. What is the page number? 159 means here is given acceleration due to gravity. Small g is not gravity. Small g is acceleration due to gravity. Why is it called acceleration due to gravity? Because if any object is dropped from a certain height in the heavenly body, then what is produced in it? Acceleration is produced. That acceleration is called acceleration due to gravity. And acceleration due to gravity differs from planet to planet. What is the acceleration due to gravity of Earth? 9.8 meter per second square. But one thing we have to keep in mind, Earth is not perfectly spherical, so the value of small g also differs from place to place. At equator, value of small g is less. At poles, value of small g is more. So, relation of g with the mass of the falling body, it is the one. Okay. So you can see here, what is this? Leaning Tower of Pisa. Still, this structure exists, but our Bhimsen is tower already demolished, destroyed because of earthquake, and again they have made new one. But it's here since more than let's say 500 years. In this leaning tower, I think it is slightly in oblique position, slightly, and it also looks like our Bhimsen Tower, right? And here from this place, Galileo Galilei, he dropped two stones, and he showed that both the stones reached on the ground together, right? Okay, so first we are, I think, going to discuss about relations of small g with the mass of falling body, and the next one is here feather and coin experiment. What is here? Feather and coin. Feather, this one, and coin, anything we can do. But here you can see one container. In this container, at first there is presence of air. Coin falls faster than feather. But in next condition, air is taken out from that container, and when they are allowed to drop, they drop together. That means, is there any air on the surface of moon? Is there atmosphere? No atmosphere. So if any two bodies are dropped or three bodies are dropped from certain height of moon, then all they will reach at the surface together at the same time. But on Earth, it's not possible because there is air resistance. So Gini and feather experiment. Next one is relation of G with its factors. So one formula is there. What is the formula of small g? Do you know the formula of small g? Small g is capital G, capital M by R square. What is small g? acceleration due to gravity. What is capital G? Universal gravitational constant. This is universal gravitational constant. Universal gravitational constant. And what is this? What is capital M? Mass of the heavenly body. What is R? Radius of the heavenly body. So, acceleration due to gravity depends upon mainly mass of the heavenly body and the radius of the heavenly body, because the value of capital G is constant. What is the value of capital G? 6.67 times 10 to the power minus 11 Newton meter square per kg square. So, relations of G and radius of the earth means they are inversely proportional to each other. It comes here. Look at this. Our earth is not perfectly spherical. So, towards the poles, the distance is shorter, and at the equator, distance is longer. That's why the value of small g is maximum at poles, minimum at equator. So, from where it came? Is it ours? I think some pages. Okay. All right. Now let's ask our presenter to present. Who is going to present first? Sonish Gurung with Super Guru. Okay, Sonish, very easy. Question is easy. Okay, find out your email and explain, right? Hey, what are you writing now? Is it your time to write? Or is that to learn?
Open the notebook. Square root. Go on, sir.
Good afternoon, everyone. I'm Sonish Gun from Gateway, standing in front of you to explain about chapter force and motion.
Finish. Tap and slide. Slide.
Slide on.
Yeah.
So, relation of G with the mass of falling body. According to the Aristotle, a Greek philosopher believed that heavier bodies experience greater acceleration while lighter bodies experience less acceleration due to gravity. And however, Galileo Galilei contradicted this motion in his experiment, where he observed that both heavier and light bodies exhibit the same acceleration due to gravity. And in his experiment, Galileo released several iron balls, different about different measures from the top of the Leaning Tower of Pisa. Here is the figure of it. And when he dropped when you drop the two iron balls from the tower, surprisingly, it found out that both of the iron balls have landed on the same time, and providing evidence that bodies of different masses fall with the same acceleration. Feather and coin experiment. In this figure, we can see that there are two figures, and in figure A, we can see that in this container there is a feather and coin, and it contains air in it. So while air is contained in this experiment, we can see that coin has fallen faster than feather, and in figure B, we can see that the coin and feather are falling at the same time because it is in vacuum, and upon inverting the tube, it is evidence that the coin falls much more rapidly than the feather, as illustration figure A. However, when the tube is using vacuum and subsequently inverted, both the coin and feather fall together. And some astronauts from Apollo 12 have conducted an experiment in the moon's surface, where they took hammer and feather and and when they dropped them in the moon surface, surprisingly they both landed on the same time. Relation of G with this factor. On the surface of the Earth, three main factors affect the value of G. They are radius of Earth, height of the surface, and depth from the surface of the Earth. G is inversely proportional to all factors mentioned above. G and radius of the Earth are from the universal of the gravitation. We have that F is equal to G into m1 into m2 by d power square. And if a body having mass m is kept on the surface of the Earth having mass m, the distance between the center of the bodies can be considered as equal to the radius of the Earth. Therefore, d is equal to r. And in second point, g and height h from the Earth's surface. Suppose a body is kept at a height h from the Earth's surface. We know that on the Earth's surface the value of g is given by g is equals to g into m by r power r square. And at the height h value is g is given by g1 is equals to g into m by r plus h whole square. And C, value of G on other heavenly bodies. If you are beyond the Earth or on another heavenly bodies, the value of G is determined by mainly two factors. They are mass of the heavenly body and radius r of the heavenly body. As G is equal to gm by r square, the value of G is directly proportional to the mass and inversely proportional to
Next next.
proportional to the square of the radius of the heavenly body. G and weight of 10 kg mass on the surface of the Moon, Mercury, Mars, Venus, and Earth are compared in the following table. So here are some lists about it. So in G in m by s square is Moon is to 1.64. and Mercury is equals to 3.61. Mars is equals to 3.75, and Venus is equals to 8.83, and Earth is equals to 8.81. And weight in Newton, Moon is equals to 16.3. Mercury is equals to 36.1. Mars is equals to 37.5. Venus is equals to 88.3, and Earth is 98.1. So some numeric problems are, so here the mass of the man is 70 kg. Weight of the man on the moon is not, we have to find out, and weight of the man on the moon also. We also know that g on the moon surface, gm is 1.67 by s square, and g on the surface of the earth, ge is 9.8 meter square. Now wait for the man on the moon. We have W is equals to m into ge is equals to 70 into 1.67 equals to say 116.9 Newton. Again, for the weight of the man on the earth, we have weight is equals to m into ge is equals to 7 into 9.8 is 686 Newton. And thus weight of the man on the moon is 116.9 Newton, and it is 686 Newton on the earth. Free fall. So here is the given picture of the figure. So we can see that when the bottle is at rest, we can see water is dropping from the bottom, and when the bottle is falling down, we can see that it doesn't leak from the free fall. When a bottle falls, both of the bottle and the water inside the experience free fall and share the same velocity. Because of this, water doesn't flow out of this bottle lower hole during the fall, and free fall occur when an object falls towards the center of the earth due to the gravity. If a body falls with an acceleration equal, therefore A is equal to Z, and it is. Thank you.
So namaskar everyone. So I am going to give presentation about the force and motion chapter, which is made by our Sonis. So in this we can see the example of Leaning Tower of Pisa. So in this, one philosopher, Aristotle, he said that the heavier bodies experience greater acceleration than the lighter bodies due to acceleration due to gravity. But Galileo Galilei conducted this notion in his experiment, where he observed that both heavier and lighter body drop at the same speed, same acceleration. In Galilei released several iron balls, different masses from the top of the Leaning of Tower of Pisa. Surprising, all these balls reaches the ground simultaneously, providing evidence that bodies of different masses fall with same acceleration. Feather and coin experiment. So in this experiment, a feather and coin is kept in one vacuum. So in this air, we can see that the coin is falling very faster than the feather, and in vacuum, they are falling at the same speed. So relation of G with this factor. So mainly the G depends on three factors. One is radius of the earth, height of the surface, and depth of the surface. So there is one formula also. F equals to G into M1 into M2 by D square. So relation. Wait. If a body having mass m is kept on the surface of the earth having mass m, distance between the center of the bodies can be considered as equal to the radius of the earth, which is that is d equals to r. G and height from the earth's surface. Suppose a body is kept at the height h from the earth's surface. We know that on earth's surface the value of g is given by g equals to g into m by r square. At height the value is given by g1 equals to gm into r plus h by whole square. Value of g in all heavenly bodies. If you are beyond the earth or on another heavenly bodies, the value of g is differ mainly in two factors. One is the radius of the heavenly body, and second is radius, and second is mass. So we can know as the formula also g equals to g into m by r square. So here small g represents acceleration due to gravity, and this g represents universal gravity constant. M represents mass, r represents radius. So he have made the different gravity on different planets. So in Moon there is 1.64 meters per second square, in Mercury 3.161, in Mars 3.75, in Venus 8.83, and in Earth 9.81. Weight in Newton, he have made Moon 16.3 Newton, Mercury 36.1 Newton, Mars 37.5 Newton, Venus 88.3, and in Earth 98.1. So here is some numerical problems. Suppose a mass of the body is 70 kg and the weight of man on the moon is what? And the weight of the man on the moon, we have to find that. We also know that g on the moon surface is 1.67 meter square, and in the earth there is 9.8 meter square. So for the weight of the man, we have w is equals to m into g. So you have made mistake here. Here should be m, because we have used the 1.6 of moon gravity. So by multiplying these two, we can do 1.6.9 Newton of the weight of the man on the moon. So to find the weight of the man on the earth, we have to w equals to m into g of earth surface. So 70 into 9.8 of earth gravity is equals to 686 Newton. So free fall. So when a body freely falls toward the earth centers under the influence of the gravity, this is known as the free fall. So when a body falls, so free fall means when a body falls freely to the center of the earth, this is known as the free fall. It is due to the acceleration due to gravity. So here is given an example of this bottle falling. When a bottle falls, both of the bottle and the water inside the experiment free fall and the share of same velocity. Because of this, water doesn't flow out of the body's lower hole during the fall. You can see this here. And free fall occur when an object falls toward the center of the earth due to gravity. So thank you.
Thank you very much. So, he has made very lovely slides and did animation also, but very less animation. If you have to see better animation, you can see the animation made by Iraj. You get that made by Iraj. I remember one joke, very quite lovely joke, right? Actually, every time Sir says Niraj and Niraj, what is there? But it may not be connected, but makes you laugh. So, some Punjabis, they came to visit in Kathmandu. Father, mother, and son, right? And then visitors, they visit one place to another. They were staying in one hotel and they went to Hamali, right? And when they were walking, they saw banana. What is it? Banana. And what is that? Son asks, "Papa, Papa, ये क्या है?" right? Then father said, what did father say? A केली है. What did he say? A केली है. And he said, Papa, एक केली नहीं है, एक केला है. And what did he say? नहीं बेटा, केले तो बड़े बड़े होते हैं, पंजाब में मिलते हैं. Because in Punjab there are, I think, much bigger kela. Oh, keli. Okay. And they were walking. They reached in Sundara. And again, some persons, actually, this is the joke before balance presence. Nowadays, those cycle wala, tokri wala, they are not allowed to sell like that. Tokri wala were selling mangoes, right? And again, son said, Papa, Papa, ये क्या है? And he said, बेटा, ये आम ही है. And he said to his dad, नहीं पापा, ये तो आम है. And what did the father say? बेटा ये आम नहीं है, आम तो बड़े बड़े होते हैं, पंजाब में मिलते हैं, ये तो आम ही है. ओह, केला केली, आम आमी. And they were just in Vishal Bazar. There is in Vishal Bazar. And Vishal Bazar means a bit crowded area, no? Many Indians, tourists, they visit Vishal Bazar area to buy the goods. They were buying. Boy was lost. Where has he gone? Where has he gone? And near to the Vishal Bazar, there is one police station. They say John Pod or something like that. They went there and complained. And then police were deployed to find out. Police caught the boy, brought there, and parents were also there. And the police asked, बेटा बेटा ये कौन है? And ये मेरी पापी है. Father says, अरे बेटा मैं तेरा पापा हूँ. And what did the son say? You know, पापा तो बड़े बड़े होते, वो पंजाब में मिलते, तुम मेरे पापी हो. So that was the joke. So remember, you make very lovely presentation, eh? So Nirajan does the work with full interest. You study in class 10, very passive. Nirajan is here. Nirajan so is space also. Example, one Nirajan, Raja Bose, another Gangu Teli. So what is given here? Oh, this is the diagram of Leaning Tower of Pisa. It looks like our Bhimsen Tower also, right? But design is of different. How many stories are? 1, 2, 3, 4, 5, 6, 7. Our is 9 stories one. And it's taller than this one, right? But this is a bit bent. In 17th century, means in 1642, 50 something years, Galileo Galilei performed one experiment to show that all the falling bodies, they fall with equal acceleration. But before him, another scientist, Aristotle, he said, heavier body has more acceleration and falls faster, lighter body has less acceleration and falls slower. But his saying was made wrong by whom? Galileo. Because scientists, they carry out the experiment and prove their saying, right? So when he dropped some heavy and lighter objects, they reached nearly at the same time. But later, what do you say? That due to air resistance, is there presence of air or not? So some may fall a bit slowly. Otherwise, in the absence of air, an elephant and an ant, when they are dropped from same height, they reach at the ground together. The astronauts of Apollo 11, Apollo 12, Apollo 13, they carried out such experiments on the surface of moon. And here is another experiment about guinea and feather experiment. So here, this presence of air, so feather is falling slowly or slower in comparison to queen. And here you know air, that's why both of them are falling Same time. Now, sometimes question can be asked, what is the conclusion of Cohen and Feather experiment? What is the conclusion of Cohen and Feather experiment? The conclusion of Cohen and Feather experiment is acceleration produced on a falling body is independent to its mass. Whether they are heavy body or light body, if they are falling freely, acceleration produced will be same, equal. They fall with same acceleration. Okay, the conclusion must be remembered. And relation of G with its factors, I already told you. What is the formula of G? Gm by r square. G equals to Gm by r square. Or another, G equals to Gm by r square. This is for the body which lies on the surface. Suppose this is heavenly body. Here is one object. So this formula is applicable over here. Hey. Now another formula. This is the center. Is here H or not? For this body, G prime equals to G capital M by R plus H whole square. On the surface, certain height. Next one, inside. Suppose another body lies here. For this body, what is the formula? Gm by R minus H whole square. Because it lies inner or not? This body lies on the surface. This lies at some altitude, like if one object or if a person is at the top of Mount Everest, then which formula can be applied? G prime equals to Gm by R plus H. So we remain on the surface of the earth. So which formula is applicable? G equals to Gm by R square. So if any object lies inside the ground, then which formula is applicable? Gm by R minus H whole square, right? So here, what is G? AC, universal gravitational constant. What is this? Universal gravitational constant. What is capital M? Mass of the body. What is R? Radius. What is this? Height. Height from the earth's surface. And here H means, or we can write here D, depth from the earth's surface. Depth from the earth's surface. So different formula we can get here. Eh? On the earth's surface, at some altitude, inside the earth's crust. Formula already given here. What about the value of G? On which factor does value of G depend? Mass of the heavenly body and acceleration due to radius of the heavenly body. G equals to, remember the relation, G equals to, G is directly proportional to what? Mass of the heavenly body. G is inversely proportional to radius, square of the radius of the heavenly body, right? More mass, more G. Less mass, less G. Here, more radius, less G. Less radius, more G. And one for, it's given here. He has brought the data. What is the data here? Value of G on different heavenly bodies. What is the value of G on moon? 1.64 or 67 meter per second square. Mercury, Mars, Venus, Earth, and Jupiter. What is the value? 25.14 meter per second square. They are more, isn't it? For example, the value of G on the earth is 9.8 meter per second square. What is given? Value of G on the earth is how much? 9.8 meter per second square. What does it mean? Do you know? Suppose this is earth. If any object is dropped from here, in 1 second it travels, its velocity is how much? Another 29 point something like that. It means what is acceleration? How do you define acceleration? The rate of change in velocity is called acceleration. The rate of change in velocity is called acceleration. Sometimes question can be asked. The value of acceleration due to gravity on the Earth surface is 9.8 meter per second square. What does it mean? It means that when a body is dropped from a children, look at here and read it. What is written here? It means that when a body is dropped from a certain height from the Earth's surface, then then its velocity changes at the rate of how much? 9.8 meter second in every second. Can you read this one? What is given? So the acceleration due to gravity on the Mercury is 3.61 meter per second square. What does it mean?
Sir, it
It
when a
means
body
that-
is dropped from a certain height from the earth,
Mercury surface, then
its velocity change at the rate of 3.61 meter
per second
every second.
in every second. So you must not write meter per second square. Velocity changes at the rate of this much
That's why meter.
every second. What happened? Why are you keeping your hands over there? Keep down. Huh? You think, come here, I'll just scratch and make the he doesn't pay the attention for his study and just hiding face. Okay. If it is said the value of acceleration due to gravity on Venus is 8.83, what does it mean? Tell. What does it mean? Okay, you are worried about itching. Now tell the answer. What does it mean? He doesn't pay attention. Busy in sketching. Back regularly, boy. Lute, boy. Yeah, again is sketch. Itching. Don't put there super glue. Sometimes our both gone. So, if the value of acceleration due to gravity on the Venus is 8.83 meter per second square, then it means that when a body is dropped from a certain height from the Venus surface, then its velocity changes at the rate of 8.83 meter per second in every second. That thing you have to remember. Understood or not? So, what is the content? What you have to do? Just remember. Okay, take out your book, read once again the portion, then I will give you some work. Now there will be some class work as well. Very passive students are here. Neither than like candidate. He doesn't come. Thank you.